Greetings everyone, and welcome to another online lecture summary for our class. This week we're talking about descriptive statistics and a little bit about results, or at least what goes into your results sections. Next time we'll be talking about inferential statistics, and that's more the tests of hypotheses and the predictions that you had, and how you're assessing those in the statistical way. But descriptive statistics are just as important. They set the stage for the study, let you know some of the basic sort of means and standard deviations that'll let people know, the average levels of scales, for example, and if those correspond to other studies looking at the same phenomenons, and a variety of other things. So it's basically the data concerning your data that shows, maybe population characteristics, various levels of each of your variables in terms of their level on the DV, let's say, or corresponding level on the DV. So in this example, you can see various, let's say, conditions of, let's say, lighting on performance. A, B, C, D, E, lighting conditions from low to high. And maybe on the left to the y-axis is some sort of performance, puzzle pieces put together or something. So those can be just as important as the tests between those. In this case, we're looking at, let's say, mean levels, and those little bars that look like hats could be illustration of error, which could also be highly important. You see that that C bar has a lot of error, and that could be a problem. So they're not just sort of related to your variables of interest also. They could be things like gender, racial sort of makeup of your data set, your ethnicity of your participants, all sorts of descriptives like that are important to show that you have some level of external validity, right? That's important for people looking to see if your studies correspond with results from other populations with samples and other studies, or, let's say gender questions. You can separate this data sometimes by gender and do further analyses based on that at the higher level. So things like gender, ethnicity, average scores on each of those measures, like I said, even things like percent responding to surveys could be descriptive statistics and very informative in terms of how the study progressed, how that methodology took place. For example, if not too many people responded to the survey, that low response rate could be troublesome. So we also have central tendency. That can be related to the sort of normal distribution and any skew associated with that. You'll talk about skew in your statistics classes, I assume. You have sort of kurtosis that you can look at, and that can create differences in how your results come out, your inferential statistics. So checking these sorts of indices of central tendency is very important. Relationships like correlations or regressions can also be descriptive in nature as long as they're not testing a hypothesis, right? So correlations between independent variables or between dependent variables may not be a hypothesis of interest, but may be telling in terms of some other things. Maybe some covariates or controls you need to add into the equations that you do to test hypotheses. So sometimes correlations can be very useful to then set the stage for the proper analyses to conduct to test those hypotheses. And regressions can even be used to replace missing data that you may have and perform other tasks that are sort of data cleanup. So even regression analyses can be part of the descriptive statistics of your data. Remember that measurement scales matter. The types of analyses you can perform are largely based on the type of scale you utilized. So very important as you're setting the stage for studies to think about, okay, is this a nominal sort of measure where you'll only be able to test these categorical differences? So maybe tests of means. If you have ordinal or interval ratio data, you can do things more like correlations. And of course, if you have specific conditions, you can test with analysis of variance and that sort of thing, but it's a little bit different. So means, correlations, and all sorts of things can be analyzed when you're looking at that sort of interval ratio or equal interval sort of data. Some of the most common descriptors we look at are things like the mean, which is the average score, the median, which is the middle score, and the mode, which is the most common score. Those can tell us different things. With qualitative data, for example, the mode is actually very important, whereas in quantitative data, the mean is what we typically talk about. The median is used in specific studies where there might be skew that could pull off certain things like averages and be deceiving. For example, if you look at income in California, The average income, I think says it's like 70 or 80,000, but that's skewed by, the few, 1%, 2% of million and billionaires out there, where most people probably make right around 40 or 50 actually. The variability is also important, as I said. The variance, of course, is the spread of scores, and you need a spread of scores to create or calculate correlations and things like that. And the standard deviation is the typical measure of that. So with IQ, it's usually, the mean is around 100, standard deviation is around 10, and you know that standard deviation up to 3 standard deviations away from the mean, if you remember statistics classes, encompasses most of the data. In the cases you see there, we have different versions of sort of the normal distribution violations there, right? So we see one that's very flat and one that's very narrow, which can be problematic when you analyze your data. This is useful, of course, these descriptive statistics, for looking at a bunch of different things, right? So descriptives like percentages or means can be used to look at different group percentages or group levels, So let's say how many males versus females answer a certain question a certain way even. For example, let's say you're looking at working individuals, you may say that 74% of the males were employed, where 84% of the women were employed. That may not be a test of hypothesis, but it may be important or descriptive of your data for some other reason. Also, different response rates may be important to see if maybe certain genders, ethnicities, certain members in the community are not responding to your surveys. That could be problematic and may hint towards future research. Of course, you're going to compare group means later for your sort of inferential statistics, but we can even look at group means for, average scores for groups like males versus females or whomever. For something like stealing, let's say, so going back to gender, you could look at, the rates for stealing for men versus women, and men will be higher than women. But the real test might be, something related to aggression and stealing. But you still may be interested to look to see what genders are doing. And then in future studies, maybe a priori, ahead of time, predict some changes there. We can also find those methodological issues like I pointed to with maybe missing data or skew, also scale information. So reliability, which is of course important for internal validity, can be assessed and kind of considered a descriptive statistic, even down to the item level within these scales. If you are speaking to your measures and certain items maybe have zero variability, judged by those descriptive statistics like frequencies and means, you may decide to throw that item out, and that can be justifiable based on the sort of information you gather at this early stage. Of course, response rates and correlations can be used, like I said, among the major variables, like between IVs or between DVs. So if you're looking at, let's say, various forms of aggression on various forms of stealing behaviors, you might want to see that sort of anger as a predictor is also correlated to, let's say, anxiety. So those two predictors may be correlated and have some sort of unique effect on that DV that you didn't hypothesize. But looking at all those in the correlation matrix or in other areas can provide all sorts of information about those variables, as well as scales and how those scales operate with other variables. So let's say you have a scale of anxiety that should correlate with your scale for depression or anger, probably in some small way. And if they correlate, which you expect, we call that convergent validity. It's converging evidence that what you're measuring is being measured accurately. We also look for discriminant validity evidence, which is things that shouldn't correlate, don't. So let's say you don't expect your anxiety scale to correlate with gender or sexuality, then you would see a non-significant correlation in that correlation matrix, and that adds discriminant validity. Those are more scale construction terms, but important to think about sometimes. Anyways, careful not to correlate information that may not have that sort of measurement scale that we expect. So nominal measures, for example, like ethnicity, should not be looked at in terms of a correlational sense, because there's no rank order there, right? Same thing with gender. It's hard to interpret correlations with gender, especially if you have sort of a male, female, and binary answer, because there's no rank order to that. If you just have male and female, there's ways to read the correlation and say, okay, if you're answered 2 instead of 1, 1 male, 2 female. If they answered 2, they're higher on the gender, and then they scored higher on anxiety, and it's a positive correlation. There's ways to interpret dichotomous variables like that in correlations, but typically categories should not be used in correlations. So what are the basics that you see in any study that you're going to pick up and what you should provide? Well, demographics, of course, right? So percent, number of males versus females. If you say, one, like let's say there was 32 females in the study representing 17% or whatever, you don't necessarily have to say the male side of that. People can usually infer that. Anyways, percent for each ethnicity that you gathered, which can point to, of course, like I said, that external validity or generalizability. Same thing with age, and remember all your statistics there. Anything like an M or an SD or any other statistics, you're going to have italicized in APA format, so keep that in mind. Anything else, whether they work or not, things like that could be mentioned at this point too, but make sure for your papers to fill out those samples as thoroughly as possible. Limited information there is problematic. Anyways, response rates, in terms of did enough people respond, we typically say around 10 to 14% is about the minimum that you would want before you say that the survey may not have been released properly or may not be gathering a representative sample. And that could lead to not a lot of diversity, basically, in typical situations. Also, missing data, eliminated responses, or sort of halo responding where they put all fives, things like that should be smithed out in the measurement stage of this, and sometimes reported in the beginning of the results section, sometimes reported in the methodology section for that scale. Let's say where you talk about the anxiety scale, you will also talk about maybe throwing out an item or something like that in that section. When we talk about correlations, like I said, these can be used to describe relationships between variables that may not be hypothesized relationships. So between IVs or between DVs or even between things like gender and, let's say, anxiety, that you may present to then say, therefore, we will control for this variable. Remember, those operate in certain ways, so remember what correlations do. In this case, it's more about how you would look to those correlations to see issues that are arising. And like I said, regression can actually be used to fill in missing values, to predict certain stuff within the sort of measurement domain. So that sort of stuff can be useful from a descriptive angle. Of course, regression is also used a lot for inferential statistics, predicting, an outcome from a predictor or a set of predictors when you're talking about multiple regression. So you can make hypotheses related to these types of things. They're just slightly more difficult, but usually what it is you're adding in that causal language. So you would say something like, anxiety, or let's go back to the theft example, stealing at work will be predicted by aggression. Something like that. So then you're saying that aggression is this predictor variable, and the strength of that prediction is really the significance that you test for in an inferential sense. In a descriptive sense, usually these things are just related to, typically missing values, things like that. Another way that regression is integrated is through structural models. This is a structural equation model presented here, which uses regression and correlation and things like that to sort of set up larger tests of a hypothesis, including the measurement scales, and typically multiple IVs or DVs. You may see these in some of the studies that you pick up. Some are just presented as a conceptual framework, and some are actually presented as a structural model that will be tested statistically. So in this one, for example, the hypothesis is actually the relationship between conscientiousness and performance. But all those other errors, we would say, are these descriptive sort of statistics related to the quality of that big 5 measure, the 16 PF, which is a 16 personality factor, right? Both of those may be measuring conscientiousness. So you expect correlations between the big 5 and 16 PF, but those correlations are really just showing that, okay, those two scales are measuring the same thing. That's like convergent validity. The 16 PF in the exam will correlate if the relationship between conscientiousness and performance is there, right? If that hypothesis is supported. But a lot of those other areas are important to see if those indicator variables, like exam 1, is actually a good indicator for performance. And that's done through all these descriptive sorts of things. So that hypothesis there is the important thing, right? But all these measurements that you're doing along the way are equally important. And like I mentioned earlier, probably discussed in your methodology section. Sometimes they make their way in the results section. Finally, it's important to actually graph some of these descriptive statistics, and some of these actually graphs will then have embedded within them the significance as well. So maybe, asterisks or something to indicate significant differences between these sort of mean levels. But you'll see a variety of them, like pie charts, for example, describing the number of males versus females in a study. These are pretty simplistic. I prefer any graphs to be somewhat more informative, so something like a bar graph, looking at, one IV here would be male versus female, the other IV would be age, and you can see there's differences between the genders and the ages on whatever that DV is. Let's say likelihood of having an accidental fall or something like that. I work with the Falls Prevention Coalition, and this is something they'd be interested in. So you see there the oldest categories, the older adults are maybe a higher frequency of fall. The youngest categories, least frequency of fall. And then you can look for any particular group. Let's say middle-aged females are at a higher rate than, let's say, middle-aged men. Some of those could be hypothesized tests, but there's a lot of descriptive information also embedded in a chart like this. The inferential stats we're talking about next week would come as asterisks or letters embedded in charts like this, showing where those bars differ from other bars, where those mean levels are significantly different than other mean levels. Correlations are also descriptive, like I said, and you'll see them in a lot of studies you pick up, and a good table to produce in research that you produce. Here, remember, you read correlation matrices by looking down, let's say the left column there. Let's go down to number 5, candy consumption. So the amount of candy they eat, and then maybe go over to 2, right, from the top column. So where 5 and 2 intersect, you see the number 0.34 with 2 asterisks there. So the correlation there would be 0.34 between disinhibition and candy consumption. And you see the 2 asterisks, which means it's p less than 0.01. So all of those correlations could be descriptive. In that case, that one correlation there is probably a hypothesis, right? And that significance would say that beyond chance, right, p less than 0.01, we see a relationship between candy consumption and disinhibition, columns 2 and 5. But you see they also integrated the means and standard deviations in this case, which is useful to provide extra information, that descriptive information, within this larger, maybe inferential test matrix. You also see line graphs. This is actually more of a bar graph, sort of a NOVA test. You see no ego depletion to ego depletion, so that's more of a condition, right? So typically you see bars here, but I just put it as a line graph just to show you that with regression, sometimes you're interested in the slopes of those lines and sometimes the differences between those slopes. But it can still be interesting to see, let's see, how high DVC, or highly disinhibited people in this case, change from no to ego depletion condition, or just the mean level of candy taken overall is displayed there. And sometimes they'll have like a line in between those two lines showing the mean of the two groups, and that can be descriptive in nature, where the inferential test would be maybe the differences in these slopes or something. Anyways, I hope this gives you a better understanding of some of the descriptive statistics that you'll need to provide in your papers and what you're consuming in some of the research out there. Remember to fill up those participants, measure sections within the methodology, and of course your results sections with all of this good information.